Welcome back. Today we're going to be working on 12D, which is comparing numbers in scientific notation. Content objective is students will be able to perform operations expressed in scientific notation. Language objective is students will be able to explain the steps to multiply and divide numbers in scientific notation. Why am I learning this? Well, it's important for real-world problems like comparing distances between planets. So first, let's remember our essential question. How are we using the properties of exponents to simplify expressions? Because you'll remember sometimes we add the exponent, sometimes we subtract them, sometimes we multiply. So we need to integrate that into our lesson and talk about when we are going to do those particular properties. So background knowledge, let's just remember real quick, coefficient has to be between 1 and 10. It's allowed to be 1, but it cannot be 10. B is an integer, so basically the exponent has to be a whole number, no fractions and no decimals. Okay, with multiplying scientific notation, let's quickly recall that we gather the coefficients, we gather the base tens with the exponents, we simplify, and then we make sure that our coefficient is between the correct range, which is between 1 and 10. You'll see here that this exponent is too large, so we're going to have to shrink it by multiplying by a -1. So to balance things out, I'm going to multiply this part of it by a +1. Again, because 10 to the -1 times 10 to the +1 is 10 to the 0, and anything to the 0 power is just 1. Multiplying a number or an expression by 1 doesn't change the value of it at all, so that's why it's okay for me to do that. So once I do that, the decimal will be moving 1 to the left, making it smaller. So my answer would be 1.91 times 10, 1.9142 times 10 to the 16th. Okay, let's quickly also recall how we did division with scientific notation. We gathered the coefficients together, so 4.3 divided by 5. Then we're going to multiply it by the exponents, so 10 to the 11th over 10 to the 23rd. 4.3 divided by 5, it gave me 0.86. Now for the exponents, you're going to do 10 to the 11 minus 23. I am subtracting the exponents because it is fraction is technically division. Division is repeated subtraction. So there is our central question right there. How are we simplifying? How are we using the properties? We're subtracting them because it is division. So here we're going to have to adjust our coefficient. Before that, let's actually simplify our exponent. We're going to get 0.86 times 10 to the -12. And like I said, our coefficient needs to be adjusted because it's too small. So I'm going to have to make it larger by multiplying it by 10 to the first. To balance things out, I'm going to multiply this part by 10 to the -1st, which is going to leave me with 8.6 times 10 to the -12th plus a -1 since we're multiplying. So yet again, we're using a property of exponents. Since it is multiplication, I'm going to add the exponents and I'm going to simplify it to 8.6 times 10 to the -13th. So we're just recalling that we need to make sure our coefficient is between 1 and 10. If it's not, we know to adjust it accordingly by either multiplying by 10 to the -1st or 10 to the +1st. Okay, so now let's go ahead and start comparing numbers. So here it says order the following from greatest to least. So real quick, what I'm going to actually show you is the scientific notation numbers converted into standard form. So 3.4 times 10 to the -5th, 4.3 times 10 to the -4th, 7.09 times 10 to the -6. Let's go ahead and write all of them out in standard form. Now, real quick, what you're going to want to do, especially when you're looking at the right-hand side, so digits after the decimal point, because it would have been easy if there was numbers in the whole numbers. I can quickly decide which number is larger, but if you're strictly looking at the decimals, what a good option would be is to kind of separate them like so. So right away, I can tell that this is the largest number. Okay, because the closer the digit is to the decimal, the larger it is. So that's the largest. This would be the middle, and this would be the smallest. Okay, so now if you take a quick look at the exponents. We have -4, -5, -6. Hopefully you see that the smaller the negative, the larger the number is. Because if you think about it, the closer you get to being a whole number, the bigger the number grows. Okay, the smaller your exponent is, the smaller your number as well. Okay, so now what if I asked you to approximate how many times bigger is one number than the other? Like for example, 4.3 times 10 to the negative fourth compared to 3.4 times 10 to the negative fifth. If I ask you approximately how many times is this number bigger than this, what would we do? Well, let's review real quick. Let's think. If I asked you how many times bigger is 6 than 2, okay, notice I said how many times bigger. I didn't say how much bigger. I had said how many times. So hopefully you come up with the answer of 3. It's 3 times bigger. Now, how do you get 3? Well, it's because you divided. You did 6 divided by 2, or you could have set it up as a fraction as 6 over 2. So, in a case like this, if they're asking me to compare 8.4 times 10 to the 19th to 2.1 times 10 to the 5th, they're saying how many times bigger. What am I going to do? I'm going to do the exact same thing. I'm going to divide. So I'm going to go ahead and put 8.4 times 10 to the 19th. And I'm going to divide it, and I'm actually put in the form of a fraction. I'm going to divide it by 2.4 times 10 to the 5th power. Now, what I'm going to do is, like before, I'm going to go ahead and pair up my coefficients, so 8.4 divided by 2.1. And then here, just because we've had experience with division already, to save myself some time, instead of putting times 10 to the 19th over 10 to the 5th, I'm going to go ahead and say that I know I'm going to have to subtract these exponents because it's division, and yet again I'm applying one of the properties of exponents. So I'm going to multiply that by 10 to the 19 minus 5. That's going to save me an extra step. So now you're just going to have to divide 8.4 divided by 2.1, and that's going to give you 4 times 10 to the 14th, because 19 minus 5 is 14. So how many times bigger is this than this? I would say 4 times 10 to the 14th times bigger. So the point of this part is just to know if they're asking you to compare how many times is one number compared to the other, you're going to have to do technically the inverse of times, aka multiplication, which would be division. So let's go ahead and practice one more officially. It says how many times bigger is 5.5 times 10 to the negative third than 1.25 times 10 to the negative fifth. So again, since they're asking me how many times bigger, and this key word, how many times, okay, because if this word wasn't there and it said how much bigger is one than the other, that's a totally different type of problem. Since it does say how many times bigger, I'm going to divide. So we're going to do 5.5 times 10 to the negative third divided by 1.25 times 10 to the negative fifth. So here what we're going to do is, just like yesterday or the previous lesson, we're going to go ahead and divide the coefficient. So 5.5 divided by 1.25. And then again, just to save myself some time, instead of rewriting it out like this, I know that this is a fraction. So fractions are division. So I'm going to go ahead and subtract the exponents. So I'm going to multiply it by 10 to the negative third minus a negative 5. I can't stress enough that you want to make sure in a case like this, it is a minus negative. Okay, a lot of students have the tendency to just write -3 minus 5 and be done, which gives them the wrong answer. So here we're going to divide 5.5 divided by 1.25, which is going to give us 4.4. And then here simplifying when add the opposite. And by adding the opposite, I do end up with a positive 2 here. So how many times bigger is this compared to this? I would say 4.4 times 10 to the second times bigger. Okay, so now moving on to number 3. At this point, I'm actually going to have you pause the video and try numbers 3 and 4 by yourself. Okay, so let's see how well we did. Hopefully first you went ahead and divided 8.2 divided by 5.2, okay, which should have given you 1.57 and so on. Now notice here I did stop to the nearest hundredths because I know that this number is going to determine whether or not the 5 is going to be rounded up or stay the same. Because again, when I'm asking you to divide exponents, if it repeats, I'm just going to be rule of thumb to round to the nearest tenth. So here that would be rounded to 1.6 times 10 to the second power because we went ahead and subtracted the exponents here, 4 minus 2, which is 2. Now real quick, I do understand that some of the students are doing fine with the step-by-step, but the part that they're struggling on is the division part. So just a quick tip on how we can be a little bit more precise and efficient with dividing. Here's what I want to suggest you do. First, your numerator is always your dividend. So that's going to be the number that goes inside. Your denominator is always your divisor. So here, the first thing you're going to do is make sure our divisor is a whole number. 5.2 is not a whole number. So I'm going to move my decimal over 1 to the right. Do the same thing here. Since I moved it 1 to the right, I'll do the same on this side. And then you take it step by step. Can 52 go into 8? No. Can 52 go into 82? Yes. How many times? Once. And that a lot of people can probably do without even estimating. So I'm going to put 52 here. It's going to be a remainder of 30, but we're going to have to bring down a 0. Now 52, how many times does it go into 300? Now I'm going to go ahead and say 52 is pretty close to 50. 50 actually goes in nicely to 300, so it goes in 6 times. So guaranteed it can't go 6 times because it's going to go over since I did round down. So I'm going to go ahead and pick 5. Okay, so let me just do some side work. 52 times 5, that's going to be 260. So I'm going to put a 5. 260 with a remainder of 40. Let's bring down a 0. How many times is 52 going to 400? So again, 52, I'm going to say it's about 50. 50 is actually going to go in nicely to 408 times. But I do understand, since I am rounding this down, I know multiplying it by 8 is definitely going to go over. But just to prove my point, let me show you. If I do 52 times 8, I'm going to get 416, which right there shows you it's too much. So the next number would have been to use a 7. So 52 times 7, 4, carry the 1, 364. Now, I know that I can keep on going, but truth be told, this is enough digits for me to determine how to round the 5, if it should stay or go up. So this is where you should stop. Okay? So that is the correct answer. Hopefully you got that it's approximately 1.6 times 10 to the second times bigger. Okay, so now go ahead and let's check out number 4. So it says the same instructions. Approximately how many times bigger is 5.9 times 10 to the negative second, then 7.2 times 10 to the negative fifth. So we're just going to go ahead and divide. And real quick, let's go ahead and practice the division part again. We're going to do 5.9, which is your dividend, and then 7.2, which is your divisor. Now here we are going to have to move the decimal over 1 place to the right. Move it straight up. Can 72 go into 5? No. Can 72 go into 59? No. Okay. So now I'm just going to add a 0. Can 72 go into 510? Absolutely. Here would be a great example for where it would be nice if you actually estimate it. I would say 72 is pretty close to 70. So my question would be, how many times does 70 go into 590? I would say about 8 times. So let's try 72 times 8. 56, 57. Whoops, that's not 5. 57. Now, is that enough, or should we add another one? That's actually enough. So I'm going to go ahead and put an 8 and put 576. We're going to borrow, which is going to leave us with 14. Bring down a 0. So here, this is going to, I'm going to estimate it again to 70. Now 70 goes in nicely to 140. In fact, it goes in 2 times. So I'm not going to use 2 because I knew that if it was 70, it would work. But because I rounded down, I know for a fact going in twice would be actually too much. So I'm going to just put a 1. This is going to be 72. I'm going to borrow, and I'm going to get 68. So now notice I'm not stopping. Okay, in the previous example, I stopped at the hundredths place because the hundredths place is what's going to determine whether the tenth is going to stay or if it's going to go up. But if you notice here, this coefficient is not good enough. I know that I am going to have to adjust it. So for that reason, I'm going to go ahead and take another digit. So here, let's bring down another 0. How many times does 70 go into 680? That's going to be probably 9 times, but let's go ahead and check. 72 times 9. I know things are going off the board, sorry. 2 times 9 is 18, carry the 1. That's 64. So that is actually enough. So I'm going to go ahead and put a 9 here, 648. Now, again, there's no point in continuing on. I just needed to know that digit. So I'm going to go ahead and write 0.819 ... because it keeps going on forever. And that's actually why we're using that approximation symbol. Okay. Here, since it is a fraction, I just subtracted the exponents, -2 minus -5. So that's going to leave me with 0.819 times 10 cubed. I'm going to have to make this coefficient larger by multiplying it by 10 to the first. So to balance things out, I'm going to multiply this part by 10 to the negative first. So that's going to leave me with 8.19 times 10 to the second, because 3 plus -1 is a +2. Now, notice having this extra 9 was nice, because after the adjustment, this now became the hundredths place. And I needed this 9 to determine whether the 1 is going to be rounded up or to stay the same. And in fact, this 9 is the reason why the 1 is going to round up to a 2. So it's approximately 8.2 times 10 to the second times bigger. Now, real quickly, if you didn't and you only went up to the hundredths place, you would have had 8.1, and there would be no digit here telling you whether or not the 1 is going to stay or be rounded up. So it's important that you have that extra digit. Okay, so now moving on. Now what we're going to do is we're going to be kind of going in between multiplying and dividing with scientific notation, but you're going to see some numbers are written scientific notation and some numbers are in standard form. So what should we do there? Well, we have choices. We can definitely turn everything to standard form, which looks something like this. All the digits are written out. Or we can turn both into scientific notation. Now, either one would work, to be quite honest, but keeping things in scientific notation is going to keep them nice and compact and, most importantly, neat. Now, if you decided to turn everything into standard form, there's a good chance you're going to maybe add too many zeros or not enough, and there can be errors with that one. So that's why I would never suggest it. So on that case, let's go ahead and convert this standard form into scientific notation. So here, I'm going to definitely decide that the decimal needs to come here. So it's going to be, real quick, 4.5 times 10 to the fifth. I'm keeping it because it's already in standard scientific notation. But this one, I'm going to have to do 7.7 times 10 to the, so starting at the decimal at 7.7, I'm going to count 1, 2, 3, 4, 5, 6. So 10 to the sixth power. So notice here, I started at where the decimal was and counted to where it actually is. Some students like to accidentally go the reverse, which caused them to put a -6 here. If you are one of those students, think for a second and ask yourself, is this a fairly large number or a small number? If so, fairly small numbers should be negative exponents and fairly large numbers should have positive exponents. So keep that in the back of your mind. So now once we have this, we know what to do. We're going to pair up the coefficients, we're going to pair up the exponents, and then simplify. 4.5 times 7.7 is 34.65. Here we can go ahead and just add the exponents. So if you wanted to make things a little bit easier for yourself, instead of writing that, you could have put 10 to the 5 plus 6. So definitely an option if you would want to save that extra step. Now, let's take a look. This coefficient is too big, so we're going to adjust it by making it smaller by multiplying it by 10 to the negative first. To balance things out, we're going to go ahead and multiply that by 10 to the positive first, which should leave me with, making this smaller, 3.465 times 10 to the 12th power. Why? Because 11 plus 1 is 12. Okay, so now with that said, I would like you to go ahead and try number 6. So same idea. You have two numbers that you're supposed to multiply. One is in standard, the other one's in scientific notation. So go ahead and give it a shot. Okay, so hopefully you went ahead and rewritten this number in scientific notation. Decimal needs to go here, so hopefully you wrote 5.8 times 10 to the, starting at decimal at the 5.8, I'm going to go ahead and count 1, 2, 3, 4, 5, so that's 10 to the fifth power, and then this number is going to stay exactly the same. Now, again, you should decide before you make this exponent negative or positive. Look back and ask yourself, this is a fairly large exponent, so is your number large? Yes. Now, if it was a negative exponent and you looked back and you're like, wait, that doesn't match up, then you should probably correct that exponent, because some students do make errors with positives and negatives, and they do make a difference. Okay, so then you collected the coefficient, collected the base 10s raised to an exponent, and you should have gotten 30.16 times 10 to the 11th. You're going to have to adjust it by multiplying this by 10 to the negative first and make it balanced, 10 to the first here, which should leave you, or make it smaller, 3.016 times 10 to the 12th power. Okay, so now same idea, but with division. Okay, so for number 7, I'm going to go ahead and turn this number here into scientific notation. First things first, this one's going to stay the same, so I'm going to go ahead and write it as such, 3.325 times 10 to the 8th power. Now here, the decimal should definitely be right here, 3.5, so I'm going to write that, 3.5 times 10 to the blank. Let's see. Well, this time, starting at the 3.5, my decimal is moving to the left. 1, 2, 3, 4. And since it's moving to the left, it's actually going to be a negative exponent, which does match up that it is a small number. Now, if I accidentally put 4, I should have went back and be like, wait a second, that's a fairly large, this is a fairly small number, and this is a fairly large number, and adjust it from there. So definitely check your work. At this point, what we're going to do is go ahead and divide the coefficient, and then, of course, divide the exponents. To save myself some time, since it is a fraction, I'm just going to go ahead and subtract the exponents. So 10 to the 8th minus 8, negative 4. So please, whenever you have a negative exponent in the denominator, please make sure you're writing minus a negative, okay? Because that's where a lot of students go wrong. Real quick, let's go ahead and practice the division. We're going to do 3.5 going into 3.325. Now here, I'm going to give a tip. Oftentimes, whoops, I went ahead of myself. Backtrack. Let's go ahead and turn this into a whole number first. Our divider is not a whole number. I'm going to move my decimal once over to the right. Do the same thing here and bring it on up. Here, 35 goes into 3. Nope. Can 35 go into 33? Nope. Can 35 go into 332? Absolutely. Now here's where things are slightly different. When you're estimating, normally when it's 5 or more, you're going to reduce it up. But in this case, because it's 35, I'm actually going to ask you to round it down. And let me explain why in the case of division. When we divide, we never want to go over, ever. So it's actually a better idea to round down if it's a 35, 45, 65, 105, and such like that. So in this case, I'm actually going to round it down to 30. So real quick, how many times do you think 30 is going to go into 332? Let's be honest, I can't put a 10. So let's try 9. So 35 times 9, that's going to be a 5, carry the 4. 27 plus 4 is going to be 31. So that's going to go pretty well, because adding another 35 would be too much. So putting a 9 here, I got 315. Let's subtract. We're left with 17. Let's bring on that 5. So now, again, we're going to estimate. So let's refer to 35 as approximately 30. How many times do you think 30 will go into 175? Let's see. 3 times 4 is 120, not enough. 30 times 5 is 150, pretty close. What about 30 times 6? That's 180, too much. So let's go ahead and try 5. 35 times 5. That's going to be 175. Perfect. So it's actually going to be going in evenly. Whoops, I don't know why I put a 7. It should be a 5 here because that's what I multiplied by. Okay, so it goes in nicely. So 0.95 times 10 to the. Here, if you add the opposite, 8 plus 4 is what gave you your 12. But you can't stop here. You're going to have to adjust your coefficient because it is too small. So multiplying this by 10 to the positive 1 to balance things out, you're going to have to multiply this by 10 to the negative 1. That's going to move my decimal once over, which leaves me with 9.5 times 10 to the 11th. How did I get the 11th? Well, since we're multiplying, we're going to add the exponents here, which would give me my 11. Okay, so with that said, go ahead and pause the video and try number 8 by yourself. Okay, so let's see how well we did. So here, 7.84 times 10 to negative 7th over 5.6 times 10 to negative 3rd. Real quick, I'm just going to go over how to do the division part of it. With estimation, 7.84 divided by 5.6. You're going to move your decimal over once to the right, once to the right. Can 56 go into 7? No. Can it go into 78? Yes, once, which is going to leave us with the remainder of 22. Let's bring on that 4. So here, prime example where estimating would make it a little bit easier. 56 is pretty close to 60. So ask yourself, how many times will 60 go into 224? Let's see, 60 times 4 is 240. I think that'd be too much. So 60 times 3 is 180. Let's try that because at least we're not going over. So we're going to do 56 times, let's see, 3. So that's 18, carry the 1, 15, 16. Let's go ahead and add another one. So that's going to give us 222. That actually works pretty nicely. So since I added one more, it's actually multiplying by a 4. So we're going to put 222, so a remainder of 2. Let's bring down a 0. Now, notice I have to go one more number, mainly because this is the tenths value, and I would need that hundredth to determine whether the 4 is going to go up or stay the same. But how many times is 56 going to go into 20? 0. So here, we're going to go ahead and say that it's going to be a 1.4 because this 0 is going to let this 4 stay the same. Now, how did I get negative 4? Again, to keep things simple, just subtract the exponents, negative 7 minus negative 3, which would, if you add the opposite, leave you with a negative 4. So the answer is 1.4 times 10 to the negative 4th power. Okay, so now, for number 9, what do we do in a case like this? They're both in standard form. Do you really want to multiply the numbers out in standard form? I hope not. It's not wrong, but it's definitely going to be tedious because you're going to be multiplying a lot of zeros, etc. So let's go ahead and turn it into scientific notation. First, I'm going to go ahead and decide where the decimal goes. I'm going to say it's right here. So first, we're going to do 1.4 times 10 to the. Starting at the 1.4, I'm going to count decimals. 1, 2, 3, 4, 5. Times, this decimal should be long there, so I'm going to put 6.4 times 10 to the. This time I'm moving to the left, so that's 1, 2, 3, 4, 5, 6, 7. Since it's negative, I'm going to multiply by negative 7. So this is not a huge jump to what we've been doing before. We've practiced turning standard to scientific and scientific to standard, so you have that skill. Now it's just a matter of applying it and then doing what we normally do. Pair up the coefficients, pair up the tens, and again, since it's multiplication, I saved myself a step and just started adding the two exponents together. This leaves me with 8.96 times 10 to the negative second. So that's going to be my answer because the coefficient does fall in the correct range between 1 and 10. Okay, so now let's take a look at number 10. So now they're asking us, how many times bigger is 1.8875 times 10 to the 5th than 2.5 times 10 to the negative second? Hopefully you remembered, if they're asking us how many times bigger is something compared to the other, we just simply divide. So let's go ahead and divide. 1.8875 divided by 2.5 times 10 to the, and since it is a fraction, it's division, so we're just going to subtract the exponents. 5 minus a negative 2. Now here, let's do some side work. 1.8875 divided by 2.5. What's nice about 2.5 is once I move the decimal over, it's just 25. 25 is a nice number because I know multiples of 25s because of my knowledge of quarters. And you do too. So how many times does 25 go into 1? Nothing. 25 going to 18? None. 25 going to 188. Let's see. I can get close to it by $1.75. So that's going to be how many quarters? It's going to be 7. So 175 is going to leave me with a remainder of 13. Let's bring down a 7. How many times is 25 going to go into 137? I'm going to compare that to about $1.25, which is 5 quarters. Notice I'm kind of getting sloppy. I want to make sure the 7 is going on top of the 8. The 5 is going on top of the 7. So this is going to be 125 with a remainder of 2 and 1. And let's bring on the 5. So perfect. How many times does 25 go into 125? That's going to be $1.25. So that's 5 quarters. So it actually goes in nicely. So here, I'm going to go ahead and write it's 0.755 times 10 to the 7th because I subtracted, and by doing that, if you add the opposite, it's just basically addition, and that's going to give you the 7th power. Now I can't stop because I'm going to have to adjust this coefficient by making it larger. Oops, that's a positive 1. And I'm going to have to balance things out by multiplying this by a negative 1. So by doing that, my decimal does move over 1 to the right, leaving me with 7.55 times 10 to the negative 6 because you're adding 7 with a negative 1. So it's I wouldn't say approximately. The reason why I wouldn't say approximately is because it went in nicely. Okay, it wasn't repeating, it didn't go on forever. So I'm going to say it's 7.55 times 10 to the 6th times bigger. Okay, so now what I would like you to do is go ahead and pause the video and try the last problem by yourself. Okay, so let's see how well we do. So here, hopefully you turn both numbers into scientific notation. You have 2.623 times 10 to the 6th over 4.3 times 10 to the negative 6. And then you divided the coefficients, divided the exponents by simply subtracting the exponents. And this is going to leave you with a 0.61 times 10 to the 12th. Why? Because if you add the opposite, it's 12. Now to adjust things, because your coefficient's too small, you're going to multiply by 10 to the positive 1, which means to balance things out, you're going to have to multiply this by the 10 to the negative first. Moving this decimal once over to the right, I'm going to be left with 6.1 times 10 to the 11th power. Why? Because 12 plus a negative 1 is 11. So that is your final answer. In fact, we're actually done for today. Thank you so much for taking the time to watch the lesson. And like always, until next time, bye.